Hey folks, welcome back to the channel. So today we're gonna have a fun experiment today where in many ways it's kind of like an airsoft video that we're gonna talk about a typical topic, but it's gonna be more of like an exercise or an example of how we can use statistics to help answer a good question. Among all three of these airsoft blowback products, which of these are statistically speaking more accurate? Or basically, in other words, while it's obvious that you can tell from just shooting them at a sheet of paper in your house, you can tell which one's going to be more accurate based on the grouping size, right? Thing that's important to consider is that, well, how much of that is really through random variation, and how much of that is really through an actual difference, right? And so, for example, if just because, say, this Viper Tech here shoots groups that are, say, an inch and a half large in grouping size, and say this GNP here shoots, groups that are, say, 2 inches wide, right? Does that mean that, in that instance, that's obviously that this one's a little bit less accurate than this one here? However, if we were to repeat this several other times, will that group size vary enough that basically, eventually, statistically speaking, there is no difference? So in other words, there is no difference in terms of accuracy if that was the case, right? So we're going to try to tackle that question today. And the reason why, this is a Marui, we're going to be looking at the Marui M4A1 gas blowback here, airsoft model, the GMP airsoft model here, and of course the Viper Tech model here. Now, during the test, we will be using this right here, and I will do a review at a different day for this product itself, but just to try to keep things consistent. And the reason why is that, as you know, if you follow this channel, I always do a WE video as well. But the problem is, this thing right here does not fit on the WE, and so I can't keep it consistent at this time right now. So the only way to keep it consistent is use the same device on all three of these models, and it would fit on all three of these right here. So we'll do that to make sure there's a consistency, and we'll have the target basically indoors for about 25 feet away, right? They're pretty much, or at least that thing is going to be zeroed for around that range, but there's going to be some variation, okay? But we'll go there and we'll first see what it looks like, and then we'll see statistically if it does make any difference. So if we look here, I'm not going to record the actual video of it's going to take too long here, but I'll just share you the results here. So this is from a Marui from about 25 feet away. Again, all of in the prone position using the same setup as the other ones. The first one, I'm aiming here, the shots land here. That's a fairly tight group right there, right? That's about, I think it was like an inch and a quarter, or an inch and a quarter for the biggest point right there. Not too bad though, for 25 feet away. Now, the next I shot again, and again it's a little bit higher. I'm aiming here, but it's landing up here. And again, the grouping is pretty tight, even tighter in this situation, right? It's about 0.7 inches right there, or 0.7 inches right there at the widest point. And then, of course, the third one here, I was again aiming here, but it kind of moved up a little bit. This one has a little wider grouping here, about almost an inch and a half, basically. Now, don't get this, I would say, don't let the whole shift in, I guess, the point of impact skew your opinion too much, right? Because each time you're moving, or each time I'm moving it, right, I could be pointing it a little bit different, right? And this goes into the whole concept of because these system here, that's a little bit more complicated. See my other videos about why that is, because it kind of, it has that arc shape, and depending on how far you are from your paper target, right, it might land at a different range. So you got to take in consideration elevation as well at a certain range, and at 25 feet. Certainly is going to be a factor here. So I think what's more important is the grouping size here, okay? And we'll talk about them. Don't worry about this one. This is just doing it without this is just like through the iron sights, just kind of do it for fun here, but I'm not including those results here. And then next up, we'll have the Viper Tech right here, right? The first round, again, same shot here, aiming here, kind of went all over the place. First one right here, second one right here, way up there, right? That's quite a bit. That's about like three or so inches. I did more precise measurements on another video, but or in another part, and we'll talk about it in a second. But and then the third shot, I didn't even land on the paper, so I can't record it. So I'm kind of gonna round that up as to pretend like that's probably like around 3 inches or higher, right? And that's kind of giving it the benefit of the doubt because it didn't land on the target. So I'm assuming maybe it landed on the left side instead of going way high. But not a good first set right there. But that could be a fluke. We don't know, right? This is coming back to that random variation scenario again. Down here, second shot, much better groupings, right? Aiming at the center right here. And then, you know, your nice little groups right there, roughly about an inch. So not too bad right there. Actually very good. And then again, the third time, right? 3 times again, aiming here and then landing 3 shots. A little bit high, but again, not too bad though, right? So that's about an inch or so of a group there. So it seems that, you know, it seems pretty consistent that it just might be this first one right here. It could have been something else that could have caused it. It could have been me too. Most likely it's me. But also at the same time, by the way, with the Viper Tech, when you load the BBs in there, I think the plastic rounds kind of get damaged occasionally by the metal or the metal lip of the mag. So it's possible that it damaged the BB so that it doesn't spin correctly. So, but you know, it doesn't seem to be an issue all the time. So that's the profile of this one. And then of course, the last one is GNP right here. Again, first one here, aiming here, 3 shots here. Second round, aiming here, 3 shots right here. Pretty tight groupings, not as good as the other two, but you know, not terrible either, right? This one's about an inch at the largest point. And then right here, third time again, grouped open up a little bit. So this is actually not, you know, super good right there. That's about 3 inches right there at the widest point. So as you can see, if you were to just look at it, and so I guess this is where statistics is important, right? Because this is, if you ever take statistics in college or in high school, right, to me it was always confusing, right? It's like, how do you use it? And finally, I have an example where we're going to use this and maybe learn something. If I'm doing this wrong, if I misinterpret, it's been a while since I've reviewed that class, but if I'm doing it wrong, let me know. But I think this is going to be more of a fun exercise that can answer a question in the real world for us. All right, so if you were to look here, right, again, this is the GNP, this is the Viper Tech, and this is the Marui, right? Based on this, you can tell, again, and ignore that part, it looks like the Marui, for the most part, is probably more consistent, right? You know, this is very nice here. And I would agree, from what my feeling is that it's very consistent here. Next up, the Viper Tech, you know, very good, very consistent. I would say pretty good. This part right here kind of makes me a little bit, wonder a little bit, right? Because it makes me think this is possibly a fluke, right? I'm not sure. But this first set was terrible. I'm not sure what happened here. But when we repeated the same 3 rounds again, right here and here, it seems to be more consistent. So that would lead me to believe that this is probably a fluke. But if I was to average the numbers, I have to include this right here, right? And it would suggest that this isn't as quote-unquote, you know, accurate or reliable as, say, the Marui here, which might be possible because the Marui has a very good reputation right there, right? And again, this fits, the results here fits my experience of it and what other people will tell you about it as well. So this, I can say this is pretty consistent. This is debatable, right? A lot of things could be driving this first one right here. But let's go into this one right here. But so far, again, to recap, this one seems to be the most accurate. This one, a little bit less, but not terrible, right? And then this one here, you know, does seem a little bit easier to describe as a little bit less accurate in general. Not significantly worse, but it does seem clearer to, if you were to compare all 3, right? This is the one that seems not terrible, but, you know, again, groups pretty large here, groups, you know, pretty big here, and then maybe we got a little lucky here. And again, I'm totally talking about groups. I'm not talking about the shift in impact, right? Because that's going to be a little bit different because the sights are I guess slightly calibrated different or zeroed differently. So that would be my initial conclusion, right? Based on my on eyeball inspection here, right? Which not wouldn't be very scientific or anything like that, right? But what we're going to try to do is basically we'll try to what's the word I'm looking for? Answer this question from a more statistical standpoint. All right. So let's take a look at the numbers and see if these are really different or not, or is there really no difference? First is we'll just graph it so we can visually see what those number points mean, right? So what I did was I actually graphed, or I put all the numbers, I measured them all out, distance from the point of aim and the point of impact. So for example, the Marui being each shot I measured how far away from the point, where was the endpoint of impact landing compared to where I was aiming, right? So it's 1 inch, 1 inch, 2 inch, pretty tight groupings there, right? And I did the same thing for the Viper Tech here, and then for the GMP Car 15 right here. And obviously numbers are a little bit hard to see right here, so let's take a look graphically what that looks like, right? I hate when that happens right there. But let me see if I can do it without causing it to change colors. Maybe not. All right, but try to look at this, right? The zero line runs across right here, right? That's the blue line right there. That straight blue line right there. That's the if it were to land right on that impact, that means it hit exactly where I was looking at, right? Which none of these shots were hitting, right? Because again, it's not an accuracy issue. It's more of a calibration issue or a zeroing issue right here. So don't worry about that right now, right? Let's just talk about something else. Ideally, right, you want these lines to be straight across, all right? So if a line was perfectly horizontal on this graph, that would indicate that there's zero variation and every shot was basically hitting exactly on the same point. That's like in an ideal world, right? Now, the converse is that the more it fluctuates, or the larger the group becomes, right, the more the more these lines would fluctuate, right? So if you were to look at the blue line right now, right, which is the Marui line, right, not too bad, right? It's a little fluctuation but it fluctuates a little bit, but not too bad. The car, GMP car 15 seems to do, like we kind of visually saw, it seems to do a little bit worse, right? It kind of, a tad bit worse, but probably not significantly worse. And then the Viper Tech, for some reason, has a couple outliers potentially, right? So it has some crazy um, gaps in the very beginning, right, where it fluctuates up and down, and then it kind of levels off afterwards, right? So it doesn't, they look like they're different, right? But they don't look like they're significantly different. And so someone looking at this might be like, we're really trying to what's the word I'm looking for? Trying to split hairs here to make a difference, a distinction between which one's accurate and which one's less accurate and which one's more accurate. But I guess if you look at this graph alone, I guess you can make an argument that the Marui and maybe even the GMP has less variability than the Viper Tech, right? But it's not certain, right? So let's run some statistics here, right? So what I did is basically I took all these numbers right here in these columns right here, and then punched it into a statistics calculator, right? So you would use this thing. There are different tests that you would use depending on the scenario, but this one, we want to know, is there a difference, first of all, between or among all these averages, right? So if I punch in all, again, this is the Marui right here, this is the Viper Tech, and this is the GMP, and you can tell here, the average right here, or the mean, right, is about 1.33 inches away from the target. So meaning if we were to aim where we were aiming at 25 feet, it lands about 1.3 inches above where it's supposed to hit, right? Pretty much for all of them, essentially. So at least that's the average, right? And then this is where we were talking about the variability, the standard deviation, right? So the standard deviation right here shows that they are all different, right? Ooh, so the Marui, which is the first back here, has the slowest standard deviation, so basically the lowest variation. The Viper Tech here, as we kind of saw, had the most variation, which is not the largest one right here, so that's not unsurprising. And then this one had a little bit of slight, or the GMP had a little higher variation than than the Marui, but not as bad as the Viper Tech. But again, the question is, are these averages and these standard deviations statistically significant, right? We know obviously from these numbers that they are, and from the graphs they look like they're different. So let's go down here. Basically, an F value of this and I'm using a p-value of 0.05. That's the number that the industry uses, basically, whether it's the statistics world or the medical field. They always use the 0.05. The crunch number in, and the p-value comes out to be greater than 0.05. And as long as the number is greater than 0.05, that means that these differences in the mean, right? Now, I'm not talking about the standard deviation just yet. Difference in the mean is insignificant. So on average, what that means, if we would go back to this chart right here, right? On average, if you were to whether you were to compare any of these, it doesn't really matter, right? You're always going to be about 1.3 inches different from where, or what's the word? 1.3 inches off target, basically, or from at least from at this distance during this test right here. However, that doesn't mean, because remember, 1.3 average means you can be at, like, say, 2.3, and another one negative 2.3, right? That could be a huge range here. So let's ask ourselves, well, what about this? Just because the average is the same, does that mean that the standard deviation is the same, right? And that's what we're really asking ourselves. So if you punch in a different test right here, right, you usually call it what they call an F test to test the variability or the standard deviation. Is there a difference, right? And this one I'm not as comfortable explaining, because I don't think I understand this one as well. But I can tell you, though, that this is where you just punch in the same set. I just picked the two. I only have a box for two of them, so I can only compare the two biggest ones. So what were the two biggest ones, right? The ones with the two biggest standard deviation was the Marui compared to the ViperTech. You know, so I'm going to compare the two biggest difference that I can find and see if there's a difference between those, right? And if there's no difference, then there's no point in looking between or adding the GMP there. So let's add the Marui's on the left side and the ViperTechs on the right side right here. And from what you can tell is that basically if you run them through, I don't know anymore what this means. Basically, the answer is, you go down to the answer and they'll tell you the interpretation here. The sample standard deviation of group 1 is considered to be equal to the sample standard deviation of group 2. Meaning that there's no difference in terms of the standard deviation, which means that it doesn't fluctuate. The average, oops, wrong one right there. The average, I found this online, by the way. I was really hoping to get this VFC ViperTech, by the way, but it's still sold out right now. I can't get it, but one day I'm gonna get that, hopefully soon. Anyway, the average right here, right, is, we found that the average is no different from each other in terms of its deviation, or in terms of where it lands. It's going to, on average, land within 1.3 inches of its target radius, right? And then in terms of deviation, even though it seems that the ViperTech is a little bit different, and even the GMP seems a little bit different, statistically speaking, none of these are any different in terms of their accuracy right there. And that's what the real statistic answer would say. Now, I think some of you folks might say, hey, look, 9 rounds isn't a whole lot to capture that, right? And you absolutely would be correct if you said that, right? Because this is the next lesson in statistics. This is what I'm starting to understand, is that if you were to fire 9 rounds, right, it's possible that they're really, truly, in reality, right, there is a difference in terms of accuracy among all these 3 airsoft models here, right? But the difference is so small that in order to detect a difference, you would need to run this maybe 100 times before you can have enough, what they call, power to detect a statistical significance or statistical difference, right? So in this situation, I only did 9 because I think 9 is a pretty reasonable. I mean, I should have just done 10, but 9 would have been a reasonable number. And from what I can tell, it's probably not going to be different with there. Now, these results could change, if you pump in maybe 50, maybe 100 rounds and repeat this test. But I can say probably with a conclusion visually, it does appear that the Marui, is the best. But again, the ViperTech had a couple errors right there, but I think that's just a random fluke there because the statistics would suggest it too. And I personally just feel that the GMP just tends to have wider groupings compared to it. But again, the numbers don't lie, and if you were to look for a definitive answer, right, in terms of who is more accurate, right, among all these systems, The answer is there isn't. So I hope y'all found that thing was kind of interesting. Let me know what y'all think at the bottom in the comment section, because I think this is something that you know, we when we run statistics, it kind of runs counter to my feelings about what I kind of would have intuitively said about this system. I would have, if I made a review about all of these, I would have just said, hey, hands down, the Marui is better of all of them. I would have said, I would have ranked the Viper Tech as number 2. Not as reliable, but when it does fire, it fires pretty accurately. And then I would have said the GMP is probably by far consistently the least accurate, but I don't think the numbers bear that right now. All right, folks, that's it for today. Let me know what's in the bottom. Sorry, this is like a long video, but I think this is one of those nerdy subjects that I think is kind of interesting.